Hello, my name is Victoria Villarreal, and this is the nervous system video discussion. I will be describing local resting and action potentials, and here is a diagram I have provided below. When neurotransmitters are interacting with receptors, they cause repeated depolarization of the neurons. Eventually, the neuron reaches what is known as its threshold membrane potential. When in a neuron with a membrane potential of -70, this is -55. When threshold is reached, a large number of sodium channels open, allowing positively charged sodium ions into the cell. This causes depolarization of the neuron as the membrane potential reaches 0 and then becomes positive. This is the rising phase. The action potential then travels down the neuron. It reaches its peak. The sodium channels close and potassium channels open. This allows potassium to flow out of the cell. The loss of positive potassium ions promotes repolarization, which is known as the falling phase of the action potential. The neuron returns to resting potential. Then the potassium channels close and the membrane returns to resting membrane potential, ready to be activated again. On my graph provided below, I have the 4 steps. Number 1, sodium and potassium gates closed. That is the resting membrane potential. Number 2, sodium gates open and potassium enters the cell. Potassium gates begin to open. Depolarization begins, the rising phase. Number 3, sodium gates close and potassium gates fully open. The potassium leaves the cells. Depolarization ends and repolarization begins, which is the start of the falling phase. Sodium gates closed for number 4, and potassium gates are also closing, which repolarization is complete.